We have one question from the chapter straight line. It says a line is such that its segment between the lines this and this is bisected at the point 1, 5. We need to obtain its equation. More clarity will come if I make the diagram here. Let's say I make one line. Two intersecting line is what I'm going to make. So this is the first, and let's say this be the other line here. And I write down the first equation of these two lines. The first line I take as the white one. This is 5x minus y plus 4 equals 0, which I can write minus 4 also. And the other one is this. The equation of this line is mentioned as how much? 3x plus 4y is equal to 4. Right. So we have one more line here. In fact, I'll be making a line segment as of now, or we can produce it later to make a line. Let's make a line only. I made a line here. And there's a midpoint. So it says a line segment such that the segment between these two lines. So the segment between these two lines is what? Let's say I take this as A and B, right? So AB is the segment, right? And it is bisected. This blue line is bisected at the point. That means we know the midpoint of this blue line as 1, 5. What we have to obtain is the equation of this blue line. Now to do so, what I'm going to do is to, let's say I take this point A whose coordinate I'm taking as say x1, y1, and say B whose coordinate I'm taking as say x2, y2. Now the first relation I can use is the midpoint, a special case of section formula called the midpoint formula. So we know that since one is the midpoint, what I can say that x1 plus x2 upon 2 should be equal to its x coordinate, which is 1. And similarly from here, y1 plus y2, this is y1 plus y2 over 2 is equal to its y coordinate, which is 5. So from here, what we can get one relation between x1 and x2. x1 plus x2 comes out to be 1 into 2, that is 2. And from here, y1 plus y2 comes out to be 10. We got one relation between x1 and x2. Now let's see what I can do later on. We can figure out from here that this point A lies on this line. So this x1, y1 or the coordinate of A will satisfy this equation. So check if I place the value of x1, y1 over here, what should we get? We get 5x1 minus y1 is equal to minus 4. Similarly, this point B will satisfy this equation as B lies on this line. This you can see is a point of intersection, is a common point on this blue and the green line. So I can now write down the equation here that should give you 3 times x2, 3 times x2 plus 4 times y1 is equal to 4. Now we have these two equations, but we cannot solve. This is 2, right? We cannot solve this equation, reason being they have 4 variables. So we are going to use to convert them into a single variable. So what I'll do from here what I can get, I can replace x2 with 2 minus x1 from this first equation. And that's what I'm going to do for the second also. I'm going to replace, say, I can write y2 as what? 10 minus y1. That's what I'm going to do, is to replace this x1 and not x1, x2 and y2. So check once again, I'm going to replace this x2 as we have obtained, and likewise I'm going to replace this y2. Now let's say if I do so, what we get as the new equation, this is 3 times, as I said, x2 is this, right? So this is 2 minus x1 plus this is 4 times y2. And what is y2 here? Y2 is 10 minus y1. is equal to 4. Now, if I solve this equation further, it is what? 3 into 2, that is 6, minus 3 times x1 plus 40 minus 4 times y1 is equal to 4. I can simplify it further. So this is minus 3 times x1 minus 4 times y1 will give you how much? This is 4, and this side is how much? 46. So if I bring it on the other side, it will be minus 46. Now that results to give you the new equation, which is what? 3 times x1 minus 4 times y1, and their difference is how much? This is 4, that's minus 42. Okay, I can see except minus, nothing is coming common, so I can reduce it like this. 3 times x1 plus 4 times y1 is equal to positive 42. Now here onwards, I'm going to solve these two equations. So this one, these are the two equations I'm going to solve. So this is equation 1 here, and this is the second equation. So if I do so, what we are going to get is the point of intersection of these two lines. That is x1. We will get x1, y1, right? Once we get x1, y1 and x2, y2, we can obtain. Now figure out, if I have to solve these two equations, what we can do. I can multiply 4 in this equation, right? Okay. So on multiplying 4 on this equation, this will be what? 20 times x1 minus 4 times y1 is equal to minus 16 after multiplying 4 to this equation. Next, I'm going to add these two equations. On adding, you can clearly see this get cancelled. This is 23 times x1, and on the other side, it is how much? 42 minus 16. That is 26. Yeah, 26. So we'll get x1 as how much? 26 over 23. So now replacing the value of x1 on this equation, right? I'll take this equation. We can get the value of y1. So from here, what you can see that y1, if kept on the right hand side, which is positive, y1 should give you how much? Should be give you 5 times x1, and x1 is what we have obtained as 26 over 23 from here, right? And as I said, I'm transposing this, so it's plus 4 over here. So y1 should give you how much? This is how much? 130. And if I take LCM as 4, so 23, right? So this is what I'm going to get the value of y1, right? So it's 23 multiplied by 4 will give you 92. Okay, so y1 comes out to be what? Y1 will give you, this is 2 divided by 4, so that results is 4, is 23, not 4. LCM is 23. So I can see that it cannot be reduced because this is not divisible. Yeah, it is not divisible. So I'll keep this as it is, which is 2 divided by 23. Now check, we got the value of x1, y1. So you can see from this diagram over here that we know the coordinate of two such points through which this blue line is passing, that is AB. And using this 2-point form, we can obtain the equation of this line. So that's what. Now, once we have obtained the value of x1, y1 and say x2, y2, we can obtain the equation of line using 2-point form. So I'll take y minus y1. As of now, I'm taking this as y1 for simpler calculation, is equal to y2 minus y1. So this minus this, which is how much? 2 over 23 minus 5, that divided by x minus x1. And so x2 minus x1, and x2 is what I'm going to take as 1. Sorry, this as x2. 26 over 23 minus 1, and that multiplied by x minus x1. So this is what we are going to do, and the simplification step is what I have to reduce this. So let's say if I continue writing, this is y minus 5. As I can see, we have the same denominator here, so they get cancelled. So finally, we have to multiply 23 into 5. So 23 into 5 gives how much? 115. So 222 minus 115. So this is 222 minus 115, and same in the denominator, it should give you 26 minus 23, that multiplied by x minus 1. One more step that involves y minus 5 is equal to, on reducing this. So if I subtract triple two 111 from triple two, I'll get what? 107. So this is 107, and this is clearly 3, that multiplied by x minus 1. So now you'll get the final answer by transposing 3 to the other side. So this is 3y minus 15 is equal to 107 x minus 1. Keeping like term, sorry, in the standard form, this is 107 times x, transposing 3y to the right hand side as well as 15 on the right hand side. Right. So it was 107. This is 107. And then transposing. Yeah, this is 107. And then if I add 15, right, on transposing 15 to this side, it's 105 plus 15 should give you how much? Minus 92 is equal to 0. So we'll say that this is the final answer of this question.